Hello, sweet faces. Welcome to this week's assignment where we are looking at random samples. We've been talking in class about how we can determine how this works. And something that you're going to notice is this is going to take a little bit of think time, right? This isn't as simple as adding things up or multiplying. We're going to have to decide a couple of things. First of all, is this random or not random? Random meaning I'm just picking from a group of people that don't have a relation to each other, right? They're not friends. They're not coming out of a movie theater. Just a good example of the general population. Not random would be asking my best friends, asking people that I know, going to the movie theater and asking people there if they like movies. It's not going to be random. We're seeking out people that are going to lean our data one way or the other. Then biased or representative. So biased, again, kind of goes into that non-random portion. So if I go to a movie theater and I ask people if they like movies, that is going to be biased, right? If I'm seeking out people that are already in that environment, the likelihood that they are going to like that is very, very strong. Whereas if I'm talking to people that are on the street, that I don't know, that are from different walks of life, then I'm going to have more of a representative example. I want to make sure that everyone's opinions are heard to have a good sample. So let's dive in. Miriam surveyed her 3 best guy friends about what lunch the cafeteria serves is the best. This is not random. And it's not random because they're her best friends. She knows who they are. And this is also going to be biased because if they eat in the cafeteria already, they are going to have a thought about what is best. Also, it could have been people that she knows that like to eat lunch at the cafeteria versus if she interviewed people that never purchase lunch at the cafeteria. We're not going to get a non-biased or a representative answer. A scientist is surveying a 5,000 acre wooded area. He picked the first 50 trees and measured their height. This is random, right? He just picked the first 50 trees. He's not seeking out a certain period, but this is going to be biased. And it's going to be biased because he just picked the first 50 trees. There's 5,000 acres in the wood. If he wanted to have a more representative example, he needs to space out the trees that he is picking and not just pick from one portion of the wooded area. A restaurant is looking for the most popular menu item. They look at every sale from the last month. So this is not random because they're looking at a specific time period, but this is representative because they're looking at every sale, not just specific ones. A teacher closed her eyes and picked 15 sticks out of a jar that are assigned to different students and averaged their most recent test scores to determine the class average. This is random. She closed her eyes. She did not pick particularly. And this would be representative because she picked at random from the class to do the average. A town council member asked one person right next to a possible construction site if they want the apartments built there. This is not random. They're seeking out people that are in close proximity to where this is going to happen. And this is also bias. And this can be biased for one of 2 reasons. The person that is close to that possible construction site, number 1, they probably live in that area. And number 2, maybe they already know about it. So if we want someone who is non-biased, or more representative, I should say, then we need to take out of the location. We need to not be in that general location. We need to take a step back and look at a more random choice of a person for that. A school wants to know how many students are interested in the sport. They only talk to the basketball team. This is non-random. They're choosing the basketball team. There's no randomness to that. And this is bias because the basketball team is very likely going to be interested in basketball and in sports for that matter. So this is not going to be bias, or this is not going to be unbiased, and it's not going to be random. All right, loves, describe a scenario based on the information below. If Tiffany wants to know who likes to eat pizza in her class, how can she get a biased result? If she wants a biased result, she can do a couple of things, and I'm not going to write answers because there's a bunch of choices, so just going to kind of talk through them here. So if she wants a biased result, one of the things that she could do is she could wait till pizza day And she could find the people at her lunch table and say, hey, I see you're eating pizza. Do you like pizza? It's going to be pretty biased. I mean, if they have pizza in front of them, obviously they like pizza. One of many examples. Anything on this page, if you have a specific example that you'd like me to check, by all means, send it to me or ask in class. Lindsay is asking who likes football. How can she get a representative sample at school? So if Lindsay wants a representative sample, she needs to look at how many kids are in the school and find a way to randomly survey them. She needs to make sure that she is not surveying people at a football game or at a sports event. So something that Lindsay could do is Lindsay could stand at the front door of the school and ask 50 different people out of 100 whether or not they like football. Just one example again. If you want a specific example checked, let me know. A survey to determine which teachers like to drink coffee. What is a way to get a non-random result? Go to the 5th grade teachers. Go to the 7th grade teachers. That would be a non-random result. A survey about which students drive to school. What's a way to get random results? Random results would be to take one grade level and poll 50% of the people. As long as we're not going to the parking lot and picking people that have cars, that would give us a non-random result. Skylar is trying to figure out how many students are in an after-school club. How does he get a random and representative result? Again, he needs to look at how many people there are that he is polling and poll a good percentage of them. So he could either choose to poll one grade. He could choose to poll a certain amount of people from each grade. As long as they are randomly selected, he's going to get a better idea of how many people are in the after-school club. Martin would like to know who is vegetarian. He would like to get a non-random and biased result. Well, I mean, Martin could just go to the vegetarian club at school. That would be non-random and biased. Or he could go to a table of people that are all eating vegetarian style food. That would be non-random and biased. All right, questions on these, bring them to class. In a class of 45 students, whoa, sorry. There we go. In a class of 45 students, 20 prefer painting. How many would want to paint if there were 1,800? So we have 20 out of 45 equals X out of 1,800. So for this one, we're going to first start by setting it up correctly and making sure that we have our relationships the same. We have to do that to make sure that we are going to have our correct ratio. So we're going to cross multiply for this. We're going to do 1,800 times 20, which is going to give us 36,000 is equal to 45x. Divide both sides by 45 to get x by itself. X is equal to 800. Over here, a factory produced 1,000 toys and 300 were defective. If we take a sample of 50 toys, how many should be defective? So there were 1,000 produced and 300 were defective. If we take a sample of 50 toys, how many should be defective? So again, I cross multiply. 5 times 3 is 15, 3 zeros equals 1,000x. If I divide both sides by 1,000, I would get 15 for my answer. X is equal to 15. Coming down here at a department store, there are 20 employees currently working, and 8 of them are part-time. If I look at 100 employees they have, how many of them are part-time? So there are 8 part-time people out of 20. How many part-time people out of 100? Cross multiply. 800 equals 20x. If I do 800 divided by 20, I get x is equal to 40. So out of that population, 40 should be part-time. A school has 500 students in grade 9 and 200 are boys. How many boys are expected to be in a class of 30? So 200 boys in the 500 students. How many boys in the 30 students? 3 times 2 is 6 with 3 zeros is equal to 500x. When I do 6,000 divided by 500, I get a value of X is equal to 12. A warehouse has 800 items in stock, 400 are clothes and 400 are accessories. If they look at 50 items, what would you expect the quantities of each type to be? So for this one, we have 400 out of 800 equals X out of 50. Now, some of you might have already been able to look at this and realize that this was 50%. If we do 50% of 50, we get 25, but you can always prove it with math. Cross multiply 20,000 equals 800x. Divide your 20,000 by 800. We get that x is equal to 25. In a city of 50,000 people, there are 15,000 that are over 60 years old. If you were to look at 500 people, how many are over 60? So 15,000 out of 50,000 compared to how many out of 500? So 15,000 times 500 gives us 7.5 million. And I'm going to divide that by 50,000, a little short on space, sorry. And we're going to find that about 150 people would be over 60 in that 500 person group. Questions on this page, please bring them with you to class. All right, continuing to find our missing value using our cross multiplication. A grocery store has 400 apples in stock and 160 of them are red. So setting up my proportion. If a customer randomly selects 80 apples, how many are red? When I cross multiply for this one, 160 times 80 is 12,800. When I divide that by 400, I get an X of 32. A library has 2,000 books and 1,500 are nonfiction. If we look at 100, how many are nonfiction? So setting it up, 1,500 over 2,000 equals X over 100. When I cross multiply, 15 times 1 is 15, 4 zeros. We're going to divide 150,000 by that 2,000. And when we do, we get an X of 75. X of 75. At a town meeting, there were 6 people out of a sampling of 20 that had college degrees. If the town of 5,000 people were surveyed, how many would have college degrees? So 6 over 20 equals X over 5,000. X is equal to 1,500. Cross multiply, divide. Over here, Jim offers 20 yoga classes out of 50. I want to know how many yoga classes are given in 500. In this one, my X is equal to 20. A zoo has 250 birds out of a total of 625 animals in the aviary. If 15 animals are caught, how many are birds? 250 out of 625 equals X over 50. Again, cross multiplying 250 times 50 divided by 625. X again is equal to 20. There are 32 students out of 40 that have a smartphone. If 500 students are interviewed, how many of them have a smartphone? 32 times 500 divided by 40 gives me an X of 400. If you have any questions on these, please let me know. If you have trouble with setting it up, if you have questions, oh wait, this is 200. This is 200. If you have questions about setting them up, if you're unsure about the cross multiplication, let me know. The space is a little bit small, so I don't have as much area as I would like to show you the full setup. So let me know. All right, last page, looking at the graphs. This is a sample from 50 students. Is this bias or representative? This is going to be representative. We have 50 students. We'll take it. That's a big enough group. Kelly's reading log. Is the sample random or not random for Mrs. Jones' 3rd grade reading class? If it's Mrs. Jones' 3rd grade reading class and it's one person, this is not going to be random. Sample from 450 students, bias or representative. This is their favorite school subject. 450 students, that's going to be representative. That's a good amount of students. Mrs. Davis's second grade class results. Is the sample bias or representative of the whole elementary school? This is probably going to be bias. It's only one class out of the whole elementary school. It's definitely going to be bias. John talked to people on the street about their favorite activity. Random or not random? Definitely random. He's talking to people on the street, not people that he knows, not seeking anyone out. And then a sample from Jefferson Middle School teachers out of 1,000 teachers in the district. Random or not random? This is not random. There's 1,000 teachers and we chose just one middle school. This is not going to be random. All right, Nuggets, questions. Bring them to class. Have a good week.